Welcome to class number 10, Unstable CX Scores due to low sample size. What makes CX scores, like the NPS, fluctuating? So first of all, they should fluctuate, right? So there is movement in your customer experience, either through the competition or what is happening in your organization. So there is a natural dynamic, right? So it shouldn't be stable itself. But the noise you are measuring can be huge, and the reason for this noise can have several reasons. The first and obvious reason is the sample size. So, of course, if you interview not so many people, for instance, you have a split, maybe segment A in Germany, and you have 50 people in there, of course, the score will be more unstable than with 100 people. And what many people forget is that it will not save your life if you simply double your sample size, because actually you need 4 times more sample size to get double stability. To reduce your variation by half, you need 4 times more sample size. So sample size is not a merit and a solution for everything. Yeah? So instead, we need to look at what can we do with this less sample size? Can we extract more information from this sample size? And actually, one of the noise and one of the variation comes from the way we are computing the score. Yeah? Especially the NPS is not a mean, it is a ratio score. Yeah? It takes the ratios of promoters, subtract the ratios of detractors. And ratios, the same way as top 2 boxes, are very fragile towards low sample sizes. So they have a higher variance. Why is it? Imagine you have 100, sample size of 100, yeah? And imagine the typical share of promoters is just 5%. Yeah? So this would mean typically we would expect 5 of 100 fall into a promoter. And if it happens that 2 are missing for some reason, you suddenly have a 40% less score in this promoter piece. Yeah? And basically, now let's see if basically the same happens for the detractor. Much more people are in the neutral zone. Yeah, then suddenly the variation due to this small change, yeah, due to 4 people who decided to not tick the 9, but this time an 8 because I had a bad day, right? Suddenly the score is largely different. So ratio scores are always more fluctuating. So you can do something about it. Either you change the score, yeah, you change it, but we will discuss what to do with that in a minute. But the way the NPS is calculated is one reason. That's also one reason why market researchers are not a friend of NPS, because it's an unstable score. Another thing which really leverages and makes it even worse is weighting. So many companies weight their customers. So the customers who respond may, customers who bring lots of revenue and others who have basically no value, like in banking, affluent customers versus retail. The value is 1,000 times higher with affluent customers. And this you see across the bank and many industries. And what companies are doing is often they wait. So basically, they take the affluent customers or the high-value customers and overweight them, for instance, by factor 10 or so. But this then, if you have low sample size, is another reason for fluctuation because, yeah, if for this example, from these 5 promoters, if suddenly 2 of them are high-value customers, but typically you would just expect half customers in this segment because of the low likelihood that someone is a high-value customer. And this then gets a weight of 10, so suddenly you have a virtual 20% of promoters. Yeah, so weighting yeah, amplifies the whole measurement problem of the NPS. So what can you do about it? Let's talk about it in the next chart. So you could, of course, get away from weighting, but then you actually need to split those splits even more. Yeah, so you need to do a high-value customer split and a low-value customer split. So what's better needs to be evaluated. So here are some simple tactics to mitigate the effect. And we talk about more elaborate tactic in the next lesson. So simple ways are, instead of computing the NPS in the standard way, you could use fuzzy logic. So you may say, oh, that's not simple, that's complicated. It depends. Everything you have understood is simple. So, and let me explain what you see here. So what you see here are the different scores of the NPS, yeah, and actually how you treat it regarding the score. Typically, the blue points are how you treat it. If someone is 6 or lower, you treat them as minus 100% NPS, yeah, and because across all customers you average that and you get an NPS score. The promoters, you treat them as 100% NPS. Yeah, because if everyone is a promoter, the average is 100%. So in the 7 and 9, you treat them as 0. That's basically how the NPS score calculation treats responses. Yeah, it's a binary thing. Bad, neutral, good. But now you could say, you know what? I do a fuzzy logic. I say, you know what? An 8 is not the same as 7. Yeah? An 8 is a little bit positive, but neutral, but positive neutral. A 7 is a negative neutral. And a 9 is positive, but not 100%, maybe 70 or so. And you may ask, yeah, how do I know which value I take? Actually, you can try it out. Yeah, you can assume some facts, and then you basically see if, on average, this same NPS score will emerge. Yeah, across many different times or splits, you can try it out, and you will find those measurements which pretty much, on average, gives the same NPS, but for the specific moment, it gives a different NPS because it acknowledges the fact that the 7 is not 8. And your customers did not mean 8, although you treat it like the same way, right? So using fuzzy logic is basically making more sense of what your customers are saying, but you still get an NPS score. What else can we do? You can boost sample, right? So for instance, for the extreme weights, for the high value customers, you can try to boost the sample. You can try to maybe reach more often out to them, or basically reach to a larger sample. Yeah, so you get really for those for this high value customers more feedback. Yeah, for instance, if something is double in value, you could basically reach out to double of persons. Okay, if it is not possible, then it's not an option, but I'm just list out here some options you could evaluate for you. You could compute the moving average with past values. Why? You may say, I cannot average out the new with the old value. Yeah, this would be a wrong value. But hold on, because neither the old nor the new value are truths. Both are highly affected for low sample size by noise. You can basically filter out this noise by simply meaning them out. Yeah, so it's a simple tactic. There are better tactics, but if you want to use simple tactics, that's one way you can do. You could also mean that with some benchmark. So for instance, the same segment or the global score. Yeah. So if the general trend is upwards, typically there's a good chance that the specific trend is also upwards. Yeah. So that's another thing you can do. But anything you do should be simulated, because you might well say, yeah, I cannot compute the average from the old with a new value. How do I know that this will be not worse than better? You only know if you do the simulation, which means you do it, and I will talk in the next lesson how to do it. But actually, you do a real time, a real life testing validation to prove that this is closer to the truth than the actual measurement. Again, your score is not the truth. Your score is highly fluctuating through biases, yeah, through sample bias, through weighting, through measurement, and so forth. Good. So before we talk about the simulation, which is needed also for this advanced method, we talk about how to calibrate your KPIs using modeling. So typically, also here it is advised to use machine learning as a modeling techniques, because it's simply more flexible, higher predictive power, and does assume less assumptions. So the idea is the following. Basically, you take your score and try to predict this score. Yeah, for instance, your NPS score of affluent customers in Germany. And then you have other splits like retail in Switzerland, ultra high net worth individuals in USA. Whatever splits you have always a score here. So and then you try to predict which score would I expect if I knew these predictors. So, and here are some things you should think about, and one thing you should not do. So first predictor is the score of last time, because there is a strong autocorrelation of scores. Yeah, if there is high loyalty in the USA, it will be the case for the next period too. There might be a change, but this is the biggest information needed to predict the score. Is basically the score of last time. Then you may also want to include the score before. Yeah. So from this, the mechanism, the model can see, yeah, was the last time eventually the outlier. You can put the change of the score in other segments. You know, the score in other segments are widely different, right? Some are low, some are high. This doesn't matter for this score. But if there is a typical change in other segments, it might be predictive for the change in this score. Yeah, because typically customers serve the same product to all the segments or to all regions. So if there was a bug or something, a new product or a new whatever service initiative, it has impact to many regions or to many segments, and typically they are correlated. Yeah? Same the score change not only of other segments but also other regions or other areas. Then, of course, the sample size, because low sample size means high variation, high change from past to future. You should actually use, instead of putting here the score of the last time, you should try out putting the mean rating. Yeah, because actually you don't want to report the mean of the NPS, because it's hard to interpret for decision makers. But actually this is more stable, a score, and how this translates into the future score can be found out by machine learning. That's the beauty of machine learning. We don't need to know how this stuff all interrelates, and oftentimes there are strong interactions where conventional statistics doesn't work at all. Yeah, it gives typically half of predictive power. So you need to leverage machine learning here. So average not all others, but use more correlating twin splits. That's another technique you can try out. Yeah, instead of looking at the change of all other segments, you can find out which segments typically correlate with this existing segment. Yeah, so typically what you need to do is the big metrics, calibration metrics, which score, which split, yeah, correlates with which other split. So you find twins, and these twins are typically more predictive to each other. So there other indicators you have about the splits might be sales numbers or churn, so real world numbers, which are basically indicators of what is happening in real world for your customers. Yeah? And churn, price initiatives, whatever numbers you track, and you may have an hypothesis that it might be useful, can be go into the model. Machine learning will find out if this is useful or not. So lastly, a note of caution. So what you also could think of is taking another item. Maybe you do an NPS survey, and then you have some items like, how do you like our service, product, pricing, or so, yeah, closed-ended questionnaire. You could think, okay, I take the average score of this segment for quality, service, etc., as a predictor for this score. Actually, it is a very good predictor, but it will still fool you. Why? Because basically, imagine you have a low sample size, and this is all important for low sample sizes only. If you have, for instance, 50 respondents here in one split, right? And the main reason for the fluctuation is the sampling and how they fall into the NPS buckets and how they are weighted. Yeah, and this sample bias, along with this bias from the weighting, applies to those items. Yeah, for instance, the quality item, the product item, etc., applies the same way. Yeah, so basically, if you have strange people in this small sample which screw up your score, they are also the reason who screws up those items. Yeah. So you are not able to predict the truth, and that's what we want to know. We want really to use this to predict the truth. And that's why this is not helpful. It is helpful to predict those scores, but it's not helpful to predict the ultimate truth because this score is, again, biased. So for this calibration modeling, as well as the simpler tools I just talked about, you need simulation. You need an exercise to find out if they get you closer to the truth. That's the method you need to apply. Basically, what you do is you take a split which is large enough. Yeah, either it's a whole sample. If you don't have big splits, you take the whole sample. But if you have large splits, yeah, for instance, retail customers in the US, there are tons of them, much more retail customers than in Switzerland, right? So this is a huge split, and with this you can sample now. You can, if you have here 5,000 or 10,000 or something over 1,000, yeah, you are pretty close to the truth. Yeah. So, and out of this 1,000 or more, you can subsample now 100, 10, 20, 30, 50. Yeah. You can take out some samples, and for this takeout samples, you can then calibrate them. You try to make this sample score better. And then you compare it with the overall score of the whole sample, because you know this is pretty close to the truth. Yeah, this is what you need to do, and with this you are pretty sure that you nailed it. So here's an example how this looked like. Yeah, what you see on the left is the score change with and without calibration. Yeah? So here the NPS score for 100 or less samples varies. Yeah, typically can vary plus or minus 20, right, for lower sample size. So in this variation, with calibration, it now gets much more stable. So, and here's the simulation result. This is the sample size. Yeah. The orange line is actually the standard error, the deviation from the truth from your scores. Yeah. So this is what you see, that or jumps up here if it's below 100, but even 100, yeah, it still has a typical fluctuation of 5. So it's in this case, so it depends on your weighting and score scheme, but it can be quite high, and you wouldn't expect that it's so high. Yeah, but anyways, this is the status quo you are in now, and the blue line is a calibrated one. So what you learn is now, hey, if I have 20 respondents or 30, this can be as stable as 150, right? So now I can report splits as low as 25 samples, right? And what you also see is that actually the calibrated line is always better than the actual line, right? Because again, your measurement is just a measurement, it's an estimation, it's not the truth. So we just want to calibrate it towards the truth. And the simulation exercise tells us whether or not we are on a good track. Let's summarize. Scores built from limited data sizes are strongly fluctuating around the truth. Part of the problem is the way we calculate the score. Yeah? Ratio scores, as well as weighting, are the big things to look at. Some easy fixes can make the score more stable. Yeah? Fuzzy logic can help. Mean out actual versus last and so forth. Or treating the weighting scheme. But actually the most efficient and most precise way to do it is use machine learning modeling. It's the most powerful way to bring every score closer to the truth. Thank you for listening, and I'm looking forward to discuss everything with you in the interactive sessions. See you then.